Hello and welcome to Chapter 7, which is the last chapter of this course, which we will be talking about maintenance, rehabilitation, and reconstruction prioritization, and how shall we come up with the best answer to fix the pavement condition. So, in the prioritization, especially when it comes to a network, how we would pick what type of maintenance or rehabilitation or reconstruction, we are going to go through two different types of prioritization. The first one would be the single year prioritization, which is going to depend mainly on ranking the different types of maintenance techniques that we can pick from, and the second one will be the multi-year prioritization, and that's gonna be using the optimization technique that we will be talking about in a second. So let's start with the single year ranking. In this type of ranking, each year the pavement typically are ranked in accordance with the ranking guidelines until the amount of money that is available at the DOT level for maintenance and rehabilitation are used up. So let's say you start with a money equal to $1 million, and you rank all the pavement section that you have, and you start fixing the first one, the second one, until you use up all the money that you have. The most common ranking criteria used for single year ranking is the first one is rank by condition, and the second ranking criteria would be the ranking by the initial cost. So the criteria can also be weighted by other factors such as classification of the road. For example, if the road is classified as interstate versus a local, so the interstate would have the priority to be fixed. Also traffic, if I have a high traffic volume route compared to a low traffic one, the high traffic would have the more prioritization. Or the annual maintenance cost. So all of those can be used as a weigh factor to be used in the ranking. And how can we prioritize the section that we have with the available fund? So this is here a good schematic of the single year ranking. So we typically start with the current condition. We need to go to the field, go to the pavement sections, and know what's their current conditions, so we will have an idea of the health of the pavement network. Based on that, we will be able to select the right treatment, as well as having a good estimate how much that is going to cost. After that, we will be able to apply some weighing factors and rank those maintenance activities and maintenance techniques by criteria, and eventually we're going to match the rank list with the budget. Some of the limitations that we may face by utilizing the single year ranking is the very first one is there is no alternative treatments are considered. Typically we would pick one treatment that has the least cost and we'll go with it. And the other limitation is the long-term impacts are not really evaluated. We don't see what would be the overall length or the longevity of the applied treatment. It would be mainly related to the ranking criteria that we pick and the associated cost. This is here an example of those are all the required projects that need to be fixed. So at the beginning I need to have the project ID, and then this is the condition level, which is basically the measured PCI, and then those are the treatments that we are recommending. For example, 76, it would require minor rehabilitation, 82 preventive maintenance, 85 also preventive maintenance, and we also need to know what's the cost in dollars or $1 million for each one of those projects. Once we identify the cost of each project, then we need to address the worst pavement first. Again, this is one of the techniques. I'm not saying this is the best, but using this one or single year prioritization, the ranking would be based on addressing the worst pavement first. So the worst pavement, that's why now we put them in ranking, and this ranking is based on the PCI. So project number 67C had the least PCI, and that's why it has the first ranking. And the way to treat it, we need to use a major rehabilitation, and the cost will be about $3 million. Versus the best one here, the best condition section is university one. Ranking here it was put as number 6 since it has the highest PCI anyways, and we needed to apply very minimal preventive maintenance, and the cost will be about $500,000. So after we looked at all the projects that we had to handle and how we put them from the worst to the best sections, now we need to know what's the amount of budget available for this agency. So let's assume that the total budget was available is $4 million. That means projects 67C and 67A will be done and completed, but we had to stop right there because by fixing the first two projects, which are the worst scenario or the worst PCI condition, then we will use up all the money that we have for the first two projects, and the rest has to go to the second or the following year. We also can have another example here based on the ranking based on the pavement condition weighed by traffic. So the weighing factor in this case is going to reflect the traffic level applied to the condition. So the way we do it, we have to assign 3 levels or 3 weighing factors based on the traffic. If the pavement section is highly trafficked, we're going to have a weighing factor equal to 0.5. If you have an average traffic, that's going to be 1. If you have a low traffic, it's going to be 1.5. So now it's the exact same table, but now we're going to do the ranking based on the pavement condition weighed by traffic, and that's why the project ID is the same. Now we are including these 2 new columns. The first one here is the traffic, so we have average, low, average, high, high, and average. And then based on the traffic classification, we're gonna assign a traffic factor that can go again from 0.5, which is highly trafficked, all the way to 1.5, which has a very minimal amount of traffic. The condition would be the same, and now we will have the weighed condition or the modified condition based on the traffic. For example, here we have an average traffic with a traffic factor equal to 1, so 1 times 67, now we're going to have 67. While for the low traffic, I'm going to have now a traffic factor equal to 1.5 times 82, that's the PCI. Now it's going to be equal to 123. That's the weight condition. And we can pick on this one here that has high traffic, which means the factor for the traffic is 0.5 and the PCI was 71. Well, multiplying 0.5 times 71, that's going to give us 36. So really now the rankings start to change because we are now including the traffic rather than only the pavement condition. Now the ranking became this project here, which is 14A, has to be fixed first, and then 14B, followed by 67C, and then 67A, all the way to University 1, number 5, and number 6 is 67B. As you could remember, when we just used the pavement condition, 67A and 67C were ranked 1 and 2, and now they are 3 and 4 once we include the traffic with the pavement condition. If we use the same budget, now projects that need to be completed based on the $4 million, we're going to finish the first one now based on the new ranking, which is 14A, and that's going to consume $2 million, and then the 14B, and that's going to consume $1.5 million, and University 1 is going to consume $0.5 million. So now we are all of a sudden we need to fix 3 projects based on the traffic as well as the payment condition rather than just 2 with the same amount of available funds. So from here again you can say that the ranking process is also referred to as a single year prioritization. Now let's shift gears to the multi-year prioritization, or MYP. Is typically a process used to objectively identify the best combination of projects over a multi-year period rather than just 1 year. So this process, in a very simplistic way, it's more or less a tool that helps make cost-effective decisions to what, where, and when. The first question that you need to answer if you are using multi-year prioritization is the what. And the what here is going to be what treatment is most cost-effective. And the where, it will be where treatment are needed. And the when question would be when is the best time or condition to program a treatment. Once you start to answer those three conditions, you will be in the right direction to apply a successful multi-year prioritization technique. So in the multi-year prioritization technique, we need to evaluate now a long-term impacts. It's not just once we put it, what's the impact on the pavement health. It's really a long-term process of various rehabilitation strategies through the following elements. So while we're trying to study the long-term effect of any treatment, we need to look at these elements. The very first one is the timing of rehabilitation action. When are you applying it? Sometimes if the road is really deteriorated and we are just trying to do some minimal maintenance, that's not going to help. Or vice versa. If you have a very good road, you don't need to do a 2-inch or 3-inch overlay. The minimal amount of rehabilitation would be enough. Also, we need to look into the economic analysis of feasible maintenance and rehabilitation alternatives. Most of the times you cannot just depend on one alternative by itself. You have to have several alternatives and then study their cost effectiveness and pick the best one. We also need to evaluate the predicted impact on the network over time for each combination of projects over a given analysis period. So the network level has several projects, and we need to see if we are fixing half of the projects, what would be the impact on the network level versus more or less than the half. So the effect of the project level on the network level in general. This is here now a schematic for the multi-year prioritization. We also, as a starting point, we need to know what's the current or the predicted condition. The current condition can be known by just simply sending a technician or an engineer to the field and observing the current condition of the pavement. Or if you have a well-developed pavement management system, you can go to the previous years and predict what would be the performance of the pavement in the years to come. So either measured or predicted, this is going to help us to select an optimal treatment and timing for each one of these segments. After we pick the treatment, we need to estimate its own cost, and once we know the cost and once we know the type of treatment, we will be conducting several analyses. The major one is the cost to benefit ratio analysis, and therefore we will be able to match prioritized list of treatments to the available budget. So as I was saying, there is a major analysis that we typically do under the multi-year prioritization, and that would be the benefit to cost ratio. So it's not just about the cost that we put using certain treatment, is also are interested on the benefit. The benefit is measured by looking at the area under the performance curve, while the cost is the present worth cost of any alternative. So if you look back to the graph that we used to draw, which is this is the time and this is the pavement condition, and we would draw the curve like this. Now the area under the curve, which is in this case, this is the amount of the area under the curve before I apply another treatment, and again goes back down. This area here, this is what I call the benefit. So the benefit of the first treatment would be this one, number 1, and the benefit of treatment number 2 would be the area number 2, while the cost is simply again the present cost of each one of those alternatives. This is here more precise way of looking at the benefit. So again, it's the area underneath the curve. This is PSI, Payment Serviceability Index, or Payment Condition Index. It can be out of 100 or out of 5, and as you could see, we're having the first construction and then maybe an overlay and another overlay, and the area underneath the curve would be the measured amount of benefit that we gained by applying such treatment. This is here another schematic for the benefit effectiveness calculation. So what we're saying again is the higher the benefit cost ratio, the more effective that alternative is. So here, as you could see, this is an existing payment condition, and looks like here the jump that happened because we did a major rehabilitation. So the PCI, after we reached a failure or trigger limit, it was bumped up to a high value, and then it took us several years to go back to the same trigger unit. So now my interest is really now to measure the area under this curve, and that will be the benefit. So the benefit is simply the area times, can be now a traffic factor, and based on this, or the traffic weighing factor, the reason why we are multiplying it by the area to adjust the procedure when used to prioritize pavement segments that doesn't serve same level of traffic. But if we have all the sections that have the same level of traffic, then it would be just the area under the curve. Here we also are comparing different benefits and the amount of money that need to be spent and at each one of those. So let's start with the existing performance. This is the existing performance. So, and we may have here two different methodologies or two different treatments that is applied, or two different scenarios, if you will. The very first scenario is we start with a very high payment condition index, and then we reach this point, which is a trigger point for treatment A or 1. So we're not really waiting that much for the section to fail like here, where once we reach this trigger point, now we're gonna start to do treatment number 1. Treatment number 1 can be maybe here 2 inches overlay and then another 2 inches overlay, and that treatment 1 in years X and Z, and that's gonna cost us a certain amount of money. Or we can wait for the original payment condition or the original payment section to reach another trigger point, which is here. So that means now we waited for extra few years, and the payment condition now is worse compared to the trigger point number 1. And now, instead of doing 2 small overlays, now I'm gonna do a major rehabilitation, let's say 4 or 5 inches overlay, and that's gonna take me a certain amount of years before I get back to the same trigger point again. So this treatment is, now we're calling it treatment 2, and it's gonna take that many years, and it should have an associated cost with it. So from here you could see there are 2 major scenarios. And the question now is, which one of these 2 scenarios gave us the best benefit to cost ratio? So to answer the question here, we need to think in a broader ideas. For example, there are several feasible treatments that can be considered. So again, sometimes it's not just a matter of a thickness of an overlay, either 2 or 4 inches. There is so many treatments that can be applied, and each one has its own life. Also, we need to think of the effectiveness of each treatment that we are considering, how effective it is, how much time and effort we need to spend, and how long it's gonna last before we come back and do major reconstruction. Also, we need to consider more factors can be used in this analysis. These factors such as the traffic levels also can be considered, and that's why we multiply the area by a factor for traffic to have a fair comparison between two different pavement sections that have two different traffic volumes. And eventually we're going to come up with solutions. Those solutions are going to be closely representing the result of a true optimization analysis. The question here is that so many DOTs that they have been facing, why the multi-year prioritization doesn't succeed in most of the times. Typically we see at so many DOTs that single-year prioritization are more common and they work fine. When it comes to multi-year prioritization, it doesn't go well. Why? The very first thing is management philosophy supports worst first. This is typically the old school of thought. If I have a bad road, I have to fix it first, and therefore I'm spending most of the money up front, and then I'm not going to be able to fix any roads in the next year or so. Also, I'm going to have an outside influence affect project selection. The outside influence can be the neighborhood, several calls from people that they want to fix the road in front of their houses, or the road that is leading to their work, and if it's in a bad condition, we will hear more and more complaints about it, and therefore we will go and try to fix it, although we may spend most of the budget to it and we're not going to be able to fix the other roads. But sometimes, again, because of the outside influence, that's what's going to happen. Or the other problem that we tend to see in multi-year prioritization is a large backlog of projects. Every year we fix one or two projects, and then we keep the others to the next year until we have a big list of projects that need to be done, and it never gets done on time. So, to have a successful multi-year analysis, we have to have a good requirements. Those requirements, once we have them, this is going to assure for us that the multi-year prioritization, it will succeed. So those requirements, first of all, we need to have a condition or inventory information. I can't stress on how much important is the very first bullet here, because if you know your pavement condition and your pavement health very well, this is what's going to help the most in picking the best treatment that has the best benefit to cost ratio. Second, you need to also to have a good performance models. The performance model is going to allow you to predict the future performance and the future performance of treatment A versus treatment B versus treatment C, and therefore you will have a good handle on the cost that you are going to spend and the benefit that you are going to gain associated with each one of those treatments. Also, you need to have a good background of several treatments and strategies that can be applied, which is going to be depending on the type of distresses that you feel it's the majority in your pavement network. And lastly but not the least, you need to have a good analysis tools, including softwares as well as hardware. So what's the requirements for developing a strategy? So to develop a strategy, we need to have a list of strategy guidelines and treatment options. So every strategy has to have several bullets we need to achieve, and what are the treatment options that we have to maintain the pavement health. We need also to know the cost of each one of those treatments, as well as having a good pavement performance models. This is here an example of a decision tree that can be used in multi-year prioritization, and that's really depending on the condition of the pavement. So if I have an asphalt pavement that has a PCI of 70 or above, I'm just gonna do preventive maintenance. If it's 69 or below, then I need to go to here and ask myself, is it a structural deterioration, present or not present? If it's present, that means I need to apply a structural overlay. If the 69 is because of a functional deterioration, not a structural deterioration, then I need to apply a functional overlay. Functional overlay is simply to regain the roughness of the road or the skid resistance of the road, while if the 69 or below PCI is because I have a structural failure such as fatigue or rutting, then I have to apply a structural overlay to gain the stiffness of the road and therefore the longevity of the pavement structure. I also can use a decision matrix. So a decision matrix can be used while developing your multi-year prioritization. So the very first thing is you need to know what's the treatment type that you're gonna need to consider. The very first one is preventive maintenance versus functional overlay versus structural overlay. The same three treatment types that we dealt with in the decision tree. And we need to understand what's the surface type. Surface type here, for all of them, we are giving here an example of the asphalt concrete. And then we need to connect it to the condition level. So preventive maintenance, for this case, it happened to be if the PCI or the pavement condition is somewhere between 70 and 100. While if I need to apply the functional overlay, if I have condition between 0 and 69 and there is no structural deterioration. But if I have a structural deterioration and the PCI is low, which is less than 70, then I need to apply a structural overlay. So what I'm trying to say here is you can use a decision matrix or decision tree. Both of them are valuable tools that you can use while you are planning for your multi-year prioritization. The action strategies that you also need to be aware of while you are developing your multi-year prioritization, the very first one is the preventive maintenance, then minor rehabilitation, major rehabilitation, all the way to reconstruction. If we recall from the very beginning of the class, this is also has to do with the pavement condition. If I have time, and this is pavement condition, and then I have the typical curve here. So if I waited very short time after the brand new construction, I can go to the field and do some minimal preventive maintenance around this area where the PCI is still very high. There is no structural failure. It might be a very minimal functional deterioration that's happening. So here I can apply preventive maintenance. PCI somewhere between 85 to 100. Minor rehabilitation is around here where it's somewhere between 70 and 85. Minor rehabilitation can be up to 2 inches overlay or a chip seal or 1 inch overlay. While if I waited till I reach a PCI around 50 to 60, then this is here a major rehabilitation including 4, 5 or even 6 inches overlay and a big fixation of the bases and sub-base and all the way to the subgrade, which we can treat it with lime or cement. And if I really did not do anything and I let the pavement reach PCI less than 50 or 40 to 50, then I am realizing that the entire structure is failing, including base, sub-base, and the subgrade. I need to do a major reconstruction. Another aspect that we need to talk about here is the prioritization analysis components. So the very first component is the benefit or effectiveness of each one of these treatments. The second is you need to know what's the life cycle cost for each one of the treatments. And therefore the third, which will be really an answer based on knowing the benefit and the cost, is the benefit to cost ratio or effectiveness ratio. Once you have this ratio, the benefit to cost ratio, then you will be able to fairly compare 2 or 3 treatments and pick the best one. It's not just about the cost. it's also about the benefit. How much benefit are you getting from each one of those treatments? So once you develop the ratio, which really here you are including both the benefit and the cost to the equation, then you will be able to pick the best treatment. So what's effectiveness? Effectiveness, really you can't measure it in a very specific way. It's non-monetary, and typically we use the area under the curve for some traffic value, and that would be the effectiveness. The benefit is monetary, or can be monetary or non-monetary. The benefit also can be used as the area under the curve for some traffic values. The monetary are typically considered saving in accidents sometimes, or travel time, or motor vehicle operation cost. All those can be included in the monetary effect or the benefit. Why? Because if I have a good treatment, let's say 4 inches overlay, I know it's going to last for 10 years or so, which means I'm not going to have a traffic delay, or it's going to reduce the accident, and therefore it's going to have higher benefits compared to a chip seal or a slurry seal or just sealing the cracks. So speaking of costs, again there's so many costs here and that need to be included in the analysis. The first one is the agency cost, the user cost, the salvage value, which we talked about before, maintenance cost, all the way to any other relevant cost over the life of the pavement. Salvage value, we talked about it before in the previous chapter, which is basically some monetary benefits which is difficult to calculate within a reasonable degree of accuracy, but again we try to come up with a reasonable value for the salvage materials